in this last section that we're going to talk about with our right triangles, we're still using our trig. We're using it kind of backwards. So in everything we've done so far, we have found side lengths. Now we are going to find the angle that we're looking for. And it involves a whole extra button on your calculator. It's so exciting. Make sure you write this down. So, we've already talked about the SOHCAHTOA, right? We know all of that. Okay? Our ratios don't change any. Okay? But on our calculator, and to go backwards, really, it's the inverse, right? Inverse is backwards isn't like opposite, right? So you really just need to write this down, okay? And the examples, of course. So I'm moving on to examples like we're actually going to have to do. Okay. So it says solve the right triangle, okay? Notice that we have C as a letter, but we don't know what either of these angles is either, okay? So we're gonna figure out what A and B are, okay? To find C, you're not gonna have to do this in this section very much, but to find C, you would just use Pythagorean theorem with the 2 and the 3, okay? But we're not going to do that right now. I just want to work on our trigonometric ratios. Okay, so in relation to B, we've got opposite, we've got hypotenuse, and we've got adjacent. Okay, but we don't know what that angle measure is. Okay, so we would say we know opposite and we know adjacent. So that's tangent. So the tangent of B is the opposite over the adjacent. So tangent of B is 2 over 3. We don't know, so previously we would have put in, like, in our calculator we would have done the tangent button and then 25, right, and all that. Okay, but this is backwards. So to find that angle, we have to do the inverse. So on your calculator, and your phone calculator does do this. I don't know off the top of my head how, but hopefully you come back to class at some point and I can show you how to do it on the school calculator. So you're using the same sine, cosine, tangent buttons, but you're going to hit second first. So you're going to hit second tangent. And you'll notice it shows up like this on your calculator. And you're going to put in that fraction, 2 divided by 3. And your parentheses, so it's always good practice. And you're going to get 33.7. That's your angle measure. That's the angle right there. Okay? You will probably like finding angles better because it's easier math on you. Just FYI. Okay? So now, let's try to find this guy, okay? Our adjacent, opposite, hypotenuse don't change, okay? So we still only know the adjacent and the opposite, so we've got tangent of A in this case, except that now that's our opposite and that's our adjacent, so it's upside down, okay? So in your calculator, you're going to do second tangent, and then that fraction goes in your parentheses, and you're going to get 56.3. Now, you won't always be asked to find both, but if you do, those two things better add up to 90, right? So be careful with your rounding to make sure that they do. Okay, they do. So I think that's all I want to say about this. Oh, and then C, you can either now use your angle and opposite and all that good stuff to find your hypotenuse, or personally, I would just use Pythagorean theorem. 2 squared plus 3 squared equals C squared. So 4 plus 9 equals C squared. So 13 equals c squared, so c equals the square root of 13, whatever that is. So this is more like what you're going to figure out. Solve the right triangle, okay? Hold on, let me see something. Oops, sorry, I have answers over there. Okay, so, oops. Again, that means we're looking for what's this angle, and what's that side, okay? So in relation, let's just do A first. So in relation to A, we've got opposite, we've got hypotenuse, and we do not know the adjacent, okay? So that means we're going to have opposite and hypotenuse, which would go opposite over hypotenuse, and that equals sine. So the sine of A equals opposite over hypotenuse. Again, second sine, you'll notice on the calculator it looks like that. 24 over 25, and we get, I don't know, hang on, let me type. 73.7 degrees. So that means that angle is 73.7. So that means C had better be 16.3. Don't just say it's 16.3. Do the math and figure it out. Okay. So erase my triangle here. So now, trying to find C, we've got, well, we don't know the opposite. The hypotenuse is still 25, and now we've got the adjacent is 24, so we've got adjacent over hypotenuse, which happens to be cosine. So we can do the cosine of C is equal to 24 over 25. So cosine, you would say this, the inverse of cosine is how you would say that. Oops. 24 over 25. Hold on, let me put in my calculator. Is 16.3. Hey, isn't that what I said it needed to be? Yay, now they are both 90. Good. And again, to find your third side, you would do Pythagorean theorem. You might want to pause because I'm about to erase this. 25 is our hypotenuse, so that means that's our equals. Okay, it doesn't matter. You could have said 24 squared plus x squared. Doesn't matter. So x squared plus 576 equals, I feel like I know what 25 squared is. I did not. Subtract x squared equals 49. Take the square root of both, x equals 7. So that side would be 7. So now we know the angles, I didn't write them in there, and the side. You have solved the right triangle. Let me know in class if you have any questions.